Hello students, as in the last lecture we had started with a new topic that is complex number. As I told, this topic it is for both the section commerce as well as science, and in the last video lecture we saw what is the exact meaning of the complex number, and the format of the complex number is what actually. Basically, whenever we say a linear equation or a quadratic equation, each and every thing has its own format. So here also in this chapter also we have the complex number as its own format, which is in the form of a plus bi, and each and everything I had explained in the last video lecture, why the mathematician had decided that he has to take the root minus 1 as I just to solve the sum further. That's it. And we know that till 10th standard we used to know that we cannot find the square root of any negative number, and of course we cannot find the square root of any negative number. But in 11th standard we come to know that yes, we can solve, but by using what? Imaginary number. So in the last video lecture I had explained how the mathematician has thought that how to replace this root minus 1 as I, and how we can solve the sum further. So I is known as iota, or else we can say as imaginary number. And there we saw what is a and b, everything, then conjugate, then 2 3 some properties based on the complex number. So let's begin with the sums based on the complex number, as the sums are from the exercise only, it is not from some any other place. Okay, it is from the exercise, and this section it is for both the stream commerce as well as science. Okay, now so here the first question it says that you have to simplify. That means you have to simplify, you have to find the answer. As here in the first question it said that key we have to find the answer for this. What is the question? Root minus 16 plus 3 root 25 plus root 36 minus root minus 625. We have to find the answer for this. Okay, so you will write equal to, as we have to find the answer for this, yes or no. And we know that this 16 minus 16 we can write it as 16 into minus 1, as in the last video lecture I had explained how we can write the negative square root with respect to minus 1, yes or no. So plus 3, this we can write as 25 into minus 1 plus root 36 into minus 1 minus 625 into minus 1. Okay, further this can be done as root 16 into root minus 1 plus 3 root 25 into root minus 1 plus root 36 into root minus 1 minus root 625 into root minus 1. So here we know that the value of I is what? Root minus 1. So we can replace the root minus 1 as I. So here square root of root 14 is what? 4. So in place of root 4 minus I we can write as minus 1, we can write as I, plus 3 into square root of 25 is 5, into, in place of root minus 1 we can write as I, square root of 36 is 6. Okay, in place of root minus 1 we can write as I, square root of, sorry, here we have minus, yes or no, square root of 625 is 25. Okay, into square root of minus 1 is I, yes or no. Further this can be done as 4I plus 3 5 is a 15I plus 6 into I is 6I minus 25I. Okay, now as here clearly we can see that each and every term contain I. So if you want you can remove I as common. Okay, so inside the bracket you will get what? 4 plus 15 plus 6 minus 25. So 4 plus 15, 19. Yes or no? So 19 plus 16, 25. So here you will get 25 minus 25i. So 25 minus 25 is 0 into I. So we know that 25 into 25 is what? 0. So we know that 0 into any number is what? 0. So here we got the answer for this sum, and see to that here you will write equal to, because we have to find the answer for this section. So here you will write equal to in place of therefore. Remember this, okay? So here we got the first answer. Okay, so let's move on to the second one. Okay, so here the second one, it says that what? 4 root minus 4 plus 5 root minus 9 minus 3 root minus 16. We have to find the answer for this. So 4 into this we can write as 4 into minus 1. Yes or no? As this the basic things I had explained in the last video lecture, how we can break the minus 4, minus 9 or any negative root with respect to minus 1. Yes or no? Plus 5 into minus 9 we can write as 9 into minus 1. You will get minus 9 only. Minus 3 into this we can write as what? 16 into minus 1. Further, 4 into this we can break this as root 4 into root minus 1. 5 into this we can write as root 9 into root minus 1. This we can write as root 16 into root minus 1. So 4 square root of 4 is what? 2, and square root of root minus 1 is what? I. Square root of 9 is what? 3, and square root of root minus 1 is what? I. Square root of 16 is what? 4, and square root of root minus 1 is what? I. So 4 twos are 8i plus 5 threes are 15i minus 3 fours are 12i. As clearly we can see that I is common. So 8 plus 15 minus 12. So 8 plus 15 is 20. Okay, 8 plus 15 is what? 23. 23 minus 12 you will get what? 11i. Okay, so 8 plus 15 is 23. 23 minus 12 is what? I. So here we got the answer. Yes or no? So the question number 1, it says that you have to simplify, as this question is there for both the stream, science as well as commerce. Okay, so maybe it is the question number 1, I guess is the question number 1 for both the section, science as well as commerce. Okay, I hope you all understood how to find the answer or how to simplify the given particular question. Okay, so for the first question here we got the answer as 0, and the second question we got the answer as 11i. Okay, so let's move on to the next sums. So here let's move on to the next sum, as it says that here we have to find the conjugate of the complex number. As in the last video lecture only I had discussed about this, how to find the conjugate of any complex number. Okay, see to that I symbol will change, only the I symbol will change, not the A. Okay, as I it is with B, so this BI the symbol will change. Okay, the A part will remain same. In short, the number without I will be same as it is, symbol will be same as it is, the symbol for BI will change. Okay, so here simply directly I will show the answer. For the first one, the conjugate will be what? You will write the sentence like this: the conjugate of 3i plus, I will show. Okay, the conjugate of 3 plus 2i is 3 minus 12. So in this way you will write your answer. Okay, so directly I will write the answer now. So simply you have to change the symbol of items. Okay, symbol of items, symbol of I. So your I is not there. Okay, so here for the first sum, the conjugate for 3 plus 2i is 3 minus 2i. For this it is 3 plus I. For the third one, minus root 5. We have to change the symbol for items, so here minus it is there, so this will be plus root 7i. Okay, fourth, 5i which is positive, so its conjugate will be what? Minus 5 root 5 minus I, so here symbol is negative, so this will be what? Plus I. Okay, so for question number 6, here we know that we'll keep this minus as it is for this part. Root minus 5 we can write as 5 into minus 1. Yes or no? Further, this we can write as what? Minus, so we can write this as root 5 into root minus 1 minus, we'll keep this root 5 as it is, and we know that square root of root minus 1 is what? I. Okay, so minus it is there and I is there, so we have to change the symbol of I, so this will be root 5 I. Okay, so therefore minus root of minus 5, answer is what? Is root 5i. So what I did here, I wrote this minus 5 as 5 into minus 1, and we can split this number as root 5 into root minus 1. Yes or no? Okay, I kept this minus outside the box. Root 5 will be same as it is because we cannot find the square root of root 5 as it is an irrational number. Root minus 1 we can write as I, and we have to find the conjugate of this part, so conjugate of this part section will be what? Positive. Okay, I hope you understood the sum. And the last one, it says that cos theta plus I sin theta, so its conjugate will be what? You have to change, simply you have to change the symbol of items, so cos theta minus I sin theta. So in this way you have to find your answer. Okay, so question number 2, I guess it is of idly of 1 mark sum. Okay, so I hope you are understood how to find the conjugate, as well as how to simplify a question whenever it it is in root minus. Okay, it contain root minus. I hope you understood the question number 1 as well as question number 2, the conjugate of the following complex number. So let's move on to some few more sums based on the complex number. Okay, so let's move on to some few more sums based on the complex number. As here it says that you have to express the following in the form of a plus bi, where a and b are belongs to r, that means real number, and I is equals to root minus 1, and then you have to find the value of a and b. So here we have some questions in front of you all. Okay, so now in short, you have to convert each and every question in the form of what? A plus bi. Okay, so it is a challenging part, we can say, converting each and every format, as the clearly we can see that the format for each and every question it is different, and when the question is different and we have to convert each and every question into one pattern, and the pattern is what? A plus bi. So let's see, before this we'll see the properties here. What is the properties? It says that whenever you have a plus bi, so here what exactly you have to do? You have to bracket open. Here you have to do what? Bracket open. Whenever, just remember this format, whenever the pattern of the question is in this form, you have to apply. Okay, whatever I will say now, okay, that all thing you have to apply. Okay, so here whenever you have this two format, bracket open, whenever I is there, bracket open, and then you have to rationalize. I hope you all might be knowing what do you mean by rationalize. What? Rationalize. Okay, so rationalizing the denominator, what is that? I will explain, just remember this format. Okay, suppose whenever you it contain one term, one complex number in the numerator and two complex number. Complex, why I'm saying, because the format of the question it will be in the form of a plus bi in this form. Okay, so whenever it contain one term, one complex number in the numerator, and 2 section here. So first thing, you will bracket open this part, and then after that you will rationalize, and you must know the property how to rationalize the denominator. Okay, this section will play an important role. I will explain how to solve this sum, don't worry about that. Now suppose there are four part, okay, and here in the middle if you have plus and minus, a plus bi, a plus bi, a plus bi, a plus bi, simply cross multiply. Okay, then after that you will get two part like this, and then rationalize. So here rationalize will play an important role, remember this. Okay, whenever yes complex number is there and the power is negative, so using the indices formula, so we know that a raised to minus m we can write as a raised to m. So using this formula we can write this minus n as 1 upon a raised to n. So these are the small properties which you have to remember, and properties you will not come to know exactly what is that, what I had explained now, until you add, until you will use these properties in the sum. So we'll take one sums based on that, and directly I will explain this properties belongs to what and what exactly we have to do. So here the first one is what? In the first one it says that 1 plus 2i into minus 2 plus I. We have to convert this given pattern, given sum into a plus bi, and you have to find the value of a and b. Okay, so as we know that whenever we have two format like a plus bi, a plus bi, simply you have to do what? Bracket open. So here we do what? Bracket open, as we have to find the answer for this. So here we'll write equal to, so bracket open, I hope you all might be knowing how to do the bracket open. So 1 into minus 2 plus I. Okay, then with this part plus 2i minus 2 plus I. So this will be what? Minus 2 plus 1 minus 2 plus I plus minus 2 to the 4 I hope you all might be knowing the simple bracket open, how we have to do a simple bracket expansion, yes or no? Take the first part, multiply it with the second whole section, take the second part, multiply it with the second whole part. So bracket open, so here we got plus minus will be minus, plus plus it is plus 2i into I is I square. Okay, so now what exactly I want to explain here, listen. So now whenever you come across the sum like I square, I cube, I raised to 4, as I told in the last video lecture only, you have to break, or else you have to find the value of I square, I cube. Okay, so as I told that you have to remember this 3 4 values. Okay, so I square is equals to what? Minus 1. Whenever you see I square anywhere, simply you have to replace the I square by minus 1. I cube is what? Minus I raised to 4 is what? 1. Suppose if you want to find any value more than 4 5 6, so in the last video lecture I had explained how to break the numbers and how to find the answer for a particular question. Okay, and whenever you see that I, don't change I. Okay, don't write in place of I root minus 1. I will be I. So what section you have to change, which part? Whenever it contain I square, I cube, I raised to 4, I raised to 5 more than 2. If it is I, so you will keep the I as it is in the question, remember this. Okay, so minus 2 number will be same, I will be same, this 4I will be same, and we know that I square value, as in the last lecture I had explained, I square value is what? Minus 1. So here we'll write minus 1 in place of I square minus 1. So this will be plus minus will be minus 2. So minus 2 plus I minus 4I minus 2. Okay, so this number we can solve this part. So minus 2, here you will get what? Minus 4 plus I minus 4I, here you will get what? Minus 3I, yes or no? So now clearly we can see that the answer which we got, actually this is of the form a plus bi, where clearly we can see that what is there in place of a, that is minus 4, and what is there in place of b, minus 3. A and b are what? They are the real number, they are the coefficient. What do you mean by coefficient? Number with the symbol. Number with symbol is known as coefficient. Whether it contain positive, so you will write the positive answer. Whether it contain negative, so here you will write negative answer. Okay, so here this question it says that what you have to express each and every format, whether it is bracket open, numerator upon denominator, whether it is any format, the final answer it should be in the form of what? A plus bi. You have to compare the answer and you have to find the answer of a and b. Okay, understood? And see to that whenever in any sum you come across I square, I cube, I raised to 4, you have to replace the value except I. Okay, I will be I only. If it is I square, I cube, I raised to 4, you have to change the value to get the final answer. So I hope you understood how to solve the sum. Okay, so here we have some properties based on this, and in this way you have to tackle the sum. So let's take some few more example based on this. Okay, so here we'll see the second example. As in the second example it says that what? Okay, I I 4 plus 3i upon 1 plus I. So here what exactly you will do whenever you come across like this, okay, this format I, then a plus bi, it is there. Here also you have a plus bi format. Okay, so first you will bracket open with this part, so here you will get one section, so this will be same as it is. After that you will rationalize the denominator. What you will do? Rationalize the denominator. So let's begin. As we have to find the answer for this, so here you will write equal to, just simply bracket open, so here you will get what? 4i plus I into I, this will be 3i square upon 1 plus I. As in the first sum only I had explained, whenever you come across I square, I cube, I raised to 4, you have to replace the value of that particular term, and then after that only you have to solve your sum. So I square, we know that it is minus 1. So 4 I, what about I will be same as it is, no need to change the I value. Remember this. Okay, note down. Okay, you have to change only the value of I square, I cube more than the power 1. If the power is more than 1, you have to change the value. Okay, so here plus 3 I square is what? Minus 1 upon 1 plus I. So here this will be what? 4i minus 3 upon 1 plus I. As we converted this pattern of the question, okay, in this form, whenever you have this form, remember, whenever you have this form numerator upon denominator, numerator contain a plus bi format, even the denominator also contain a plus bi format. There is only one single method, is what? Rationalizing the denominator. So now let's begin how to rationalizing the denominator with conjugate property. I hope you all might be knowing what conjugate property. Simply you have to change the symbol of I, so this will be 1 minus I upon 1 plus I. Okay, a basic algebraical, as this all things you had studied in your lower standard. Okay, what is rationalize, how to bracket open, how to bracket expand, how to multiply, each and everything you had studied in your lower standard. As here the connection is multiplication, so we have to multiply the numerator part. Okay, we have to multiply the numerator part as well as the denominator part. Okay, so now, and see to it that whenever you are rationalizing the denominator, note rationalizing the denominator, see to it that the denominator section, it will get converted to a plus b and a minus b format, so which we can write as what, a square minus b square. Once again I will explain, whenever you do rationalize to the denominator part, so that denominator section, always and always it will get converted into a plus b, a minus b, which we can write as a square minus b square. So here also clearly we can see that here we have the same term with the opposite symbol, same term. Okay, so sorry, here minus will come, sorry, as we have to rationalize. So here you will write what, rationalizing the denominator. So what do you mean by rationalizing the denominator? If it contain plus, so here you will write minus. Okay, so here now rationalizing the denominator, as you do the rationalizing the denominator, this property if you apply, see to it that the denominator section, it will get converted into a plus b and a minus b format for each and every sum, whenever it is based on numerator upon denominator format. And clearly we can see that here we have the same term with the opposite symbol, so this we can write as a square minus b square. Why? Here we can consider one as a and I as b, so a square minus b square. And what about the numerator? Bracket expansion. Bracket expansion. Yes or no? First we'll take 4i and bracket open with this part. Then you will take minus 3i and then bracket open with the second term. Okay, first term the whole bracket, then second term the whole bracket. Then after that. Okay, so here bracket open. So here you will get 4i minus 4i square minus 3 minus minus plus 3i upon 1 square is 1 minus I square. Okay, so just now only I had explained, whenever you come across the sum I square, I cube, I raised to 4, you have to change the value first, as we did in the first step. Yes or no? After the bracket expansion. So here also after bracket expansion, you have got the value of I square, and see to that whenever you come across I square, I cube, I raised to 4 more than the power, okay, if it is I, it's okay. Whenever the power of the I is more than 1, more than 1, okay, so you have to change the value. So here we know that we'll keep this 4i as it is. I square, we know that it is minus 1. Yes or no? As this all things I had explained in the last lecture, how you can generate the value of I square, I cube. Yes or no? In easiest method, I tried my level best to explain this part. Okay, as in the last video lecture I had explained how to find the values. Yes or no? Just try to remember the ready-made value for this. I square will be what, minus 1, I cube will be what, minus I, and I raised to 4 is what, 1. Just simply remember these three values. Okay, not all four values, just three values. Okay, so now I square, in place of I square I wrote minus 1 minus 3 plus 3i upon 1 minus, in place of I square we can write as minus 1. Okay, so after this will be what, 4i minus minus will be what, plus minus 3 plus 3i upon 1 plus 1. So after this 4i, okay, plus 4 minus 3 plus 3i upon 1 plus 1 is what, 2. Here also we can do the like terms, we can solve the like terms. Okay, so 4i plus 3i and 4 and 3, so these two numbers are without I and this two number is with I. So according to the format we know that first we write a and then we write bi term. So first we write the real number and then we write the imaginary part. Yes or no? So 4 minus 3 is what, 1. 4 plus 3 is what, 7. Understood? 7 what? Okay, 7i upon 2. Simply separate the denominator, so here you will get 1 upon 2 plus 7 upon 2 I. as clearly we can see that we had converted this whole section into what? A plus bi format. So just simply see what is there in place of a. So in place of a is 1 upon 2, and check what is there in place of p. It is 7 upon 2, and just simply see the coefficient. Coefficient means what? Number with symbol. So here the positive answer is there, so a will be 1 upon 2 and b is what? 7 by 2. So in this way you can find your answer. So I hope you understood how to solve. It is just a basic algebraical thing as you used to do in algebraical expression. Okay, the chapter was there, algebraical expression, in ninth, okay, ninth, 8th standard. So just basic rationalizing the denominator, and then basic bracket open, bracket expansion, and here you have to use the concept called as what? Whenever the power of I is more than 1, if it contain I square, I cube, I raised to 4, you have to replace the value. Okay, so rationalize section will play an important role for this types of sum. Okay, I hope you understood the sum. Okay, so let's move on to the next sum. So here the next sum, it says that what? 2 plus I upon, here we have 2 bracket. Okay, as we know that whenever you here we have 2 bracket, first we have to expand this bracket and we have to convert this 2 bracket into 1 bracket. So now we'll see how to convert. We'll keep this 2 plus I as it is, yes or no? Bracket expansion, we know that how to do. First multiply the first term with the whole section, take the second part, multiply with the whole section. So this will be 2 plus I upon bracket open, so this will be 3 plus 3 2s are 6I. This will be what? I minus plus minus 2I square, yes or no? So the numerator section will be same as it is. As per the rule, we have to change the value of I square, I cube, I raised to 4 whenever you come across the power of I, it is more than 1, more than 1, then only you have to change the value of I. So here this 3 will be same, 6I will be same, I will be same. You have to change the value of I square, and we know that I square is what? Minus 1. So just remember, try to remember this, just 4 values. So 4 values, this 4, not 4 values, just 3 values: I square, I cube, I raised to 4. Okay, so this 3 values will play an important role in your first exercise. Okay, so after this, 2 plus I upon 3 plus, so this we can write as what? 5I minus plus minus minus plus 2. So this will be what? 2 plus I upon 3 plus 2 is what? 5 upon 5I. So here I converted this format into this section, and this section look like what? Just now only we had solved the sum. Okay, just now only we solved the sum. Okay, just now only we solved the sum. Whenever you have the format in simple and short, I will say that you have to convert this whole and soul format into what? A plus bi upon a plus bi, and then rationalize. Whenever you come across numerator upon denominator section, see to it that you have to convert the part into a plus b and upon a plus b and then rationalize. Okay, in short and simple language I will say that. Okay, and here I wrote the property how to expand, how to solve the sum. Okay, after this I guess you can try by yourself, because this part it look like what? This section. And after this we know that exactly what we have to do. We have to rationalize the denominator. Rationalize means just simply you have to change the symbol of this item. Means rationalize the denominator means by using the conjugate property. 5 plus 5I, conjugate will be 5 minus 5I. So rationalizing the denominator. Okay, and then rest you have to solve this sum by this section, this method. I hope you can try by the remaining sums. The remaining part you can try by yourself. So please try to solve this sum by yourself and try to find the answer of a and b. So first you will convert this form into a plus bi upon a plus b, and after this you will convert your answer in term of a plus bi, after comparing where you will get the value of a and b, as here in this question we got. Okay, so I hope you all understood all the sums, all the concept based on the complex number. As in this video lecture we saw a basic thing, basic concept, yes or no? Okay, how to find the conjugate, how to find the answer, and how to express the following into form of a plus bi, and where you have to find the answer of a and b. Okay, so almost in this lecture we had covered some basic concept based on the how to find the value of a and b, and then even the conjugate of the complex number. And in the last video lecture we saw what exact thing, exact definition of the complex number, the properties based on the complex number. Okay, so the remaining part, remaining sums based on this, we'll see in the next lecture. Till then, goodbye, see you in next lecture.